Alright, so today we're going to talk about graphing radical functions. The easiest method to graph a radical function is to figure out what its parent function is and transform it. Move it up, down, left, right, make it bigger, make it smaller, reflect it. Okay, but before we can do that, we need to figure out what the general graph of the parent functions are. Okay, once we figure it out, we can use those parent functions for all the problems that we have. Just a matter of figuring out what the parent function is. So in problem number 1, that's exactly what we're going to do. We're going to figure out what the parent functions look like in a graph, and then we're going to graph them. So we're first going to start with the function of f of x. So we're going to graph f of x is equal to the square root of x. Now, in order to graph this, I'm going to follow two general rules. Rule number 1 is that I'm going to avoid irrational numbers by using perfect squares for x. And the second rule is avoid negative radicals by only using positive numbers. Okay, so what does it look like? I'm going to draw a table of x and y values, and I'm going to begin plugging values for x and getting values for y. And the values of x that I'm going to plug in are very specific. I chose them because they're perfect squares. That way I can avoid radicals. So I'm going to pick 0, 1, 2. Actually, I'm not going to pick 2 because it's not a perfect square. The next one I'm going to pick is 4 and then 9. And then when I plug them in, I would start having the square root of x, which is 0 for 0, 1 for 1, 2 for 4, and 3 for 9. And then I'm going to go back and graph them. Okay, I'm actually going to use the same coordinate plane for both expressions because that allows me to show you the difference between the two. Okay, so 3 x-axis, and remember, whenever you graph, make sure to label correctly everything. Okay, otherwise you're doing it wrong. Okay, nobody will take you seriously if you don't label all your parts. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and 9, of course. 1, 2, 3. The negatives. Okay, so with the blue pen, I'm going to draw the first one. So x coordinate is 0, y coordinate is 0, 1, 1, 4, 2, and then the last one is 3, 9. And that is f of x is equal to the square root of x, or the parent function of the square root of x. Okay, we're going to do exactly the same process for the cube root, and we're going to compare the difference. Now, for the cube root, we have less limitations. Okay, we're still going to avoid irrational numbers by using perfect cubes, but that's it. Okay, so let's actually draw the table over here. Okay, so you have x y. The perfect cube roots that I'm going to pick are negative 8, negative 1, 0, 1, and 8. With the y coordinates of negative 2, negative 1, 0, 1, and 2. Okay, now let's look like what this graph looks like. Okay, so we still have 0, 0, but we now have negative 1, and then 2 and 8, which is all the way over here. That's only half of the graph. The other one is right here. And the red represents our f of x is equal to the cube root of x. Now let's talk about the differences between the two. First, this one, f of x is equal to the cube root of x, has a domain of all reals. Okay, and a range of all reals. Compared to the limitations that the square root of x has, in which the domain, so we're going to write domain here, is from 0 to infinity, and respectively the range is also from 0 to infinity. Okay, so very different types of problems. Okay, now you don't have to remember what the domain of range is, but once you graph it, you're going to realize that one of them keeps going on forever, the other one has a very specific space in which in the first quadrant you have to use. Now these domains of range are going to change as you move it up and down. Okay, specifically with the square root, but for right now, that's how you do problem number 1. Okay, and from now on, I'm going to use those coordinates that I found out here because they work for all of them. So for problem number 3, we're going to talk about graphing using the parent functions. Your first step should always be to identify the parent function. And when dealing with radicals, okay, you just have to look at the radical itself. Since we have a square root, the parent function is, let's write it over here, f of x is equal to the square root of x. And the cool thing about it is that we can actually use the coordinates that we found in problem number 1 in this as well. And those coordinates are, in order, 0, 0, 1, 1, 4, 2, and 9, 3. Okay? For step number 2, okay, let's write the original coordinates. That we got from problem number 1. What we're going to do is multiply the y coordinates by whatever a is. Now a, remember, is the number in front of the coordinates. So in this case, a is equal to negative 1/2. So 4, 2, okay, and then 9, 3. So we're going to go back and multiply all those numbers by negative 1/2. So multiply by negative 1/2, multiply times negative 1/2, multiply times negative 1/2, multiply times negative 1/2. Now whenever you multiply by a negative number, it's a reflection. Whenever you multiply by a number less than 1, is a shrinking. So the graph is going to be a little bit thinner. So let's actually start drawing the graph. Now this is not the final graph. This is just a sketch of the first transformation. Okay, to help us out once we get to the second one. Now what I'm also going to do is draw the parent function as well to show you what happens with each transformation. Okay, so the parent function is going to be the blue one. Okay, let's don't forget that we need to write the correct numbers. 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 1, 2, 3, 1, 2, 3, negative 1, negative 2, negative 3. So the parent function is 0, 0, 1, 1, 4, 2, 9, 3. That's our parent function. When we multiply it by 1/2, this is the new numbers that we're going to get. We still have 0, 0, which is perfect. But now we're going to have negative 1/2, which is in the bottom right here. Then we're going to have at 4, negative 1. And at 3, we're going to have, at 9, we're going to have about 4 point, we're going to have 1.5. So somewhere around here. So that's, so far we've done the second step. Okay? And it's actually, this is just y is equal to the negative 1/2 of x. Now the last step is to move it up and down, left or right, depending on how many units we have here. And here. One of them moves it left and right, the other one moves it up and down. But we're going to do it both together. Since we know, okay, we have to move it 3 units right and 4 units or 1 unit up, that's exactly what we're going to do. We're going to grab each point, move them 3 units right and 4 and 1 unit up. All the points. And in yellow we have the final graph. Now notice also how the graph change. Okay. Now what I'm gonna do now is erase the parent and the second child function to show you what the final graph just looks as by itself. Okay, you don't have to do this, but it's a good idea to do it so you're not confused which one is which. Okay, so the final graph is the one in green. Okay? Now we're going to do a cubic root function and we're going to graph it as well. Like before, we first need to identify what type of function it is. Then we need to use the parent function that we found in problem number 1. Use those coordinates to graph it. Okay? And continue doing the transformations. Alright, so the parent function in this case is f of x is equal to the cube root of x. That means that the coordinates that we're going to use are, I'm not going to use a table this time, it seems a little bit more organized. Negative 8, negative 1, 0, 1, and 8. With the y coordinates of negative 2, negative 1, 0, 1, and 2. Okay? Now, because we have an a of 2, what we're going to do for all the y coordinates is that we're going to multiply them by 2. So the x coordinates stay the same. But the y coordinates are now going to be multiplied by 2 because that's the 8 value that we have. So that means that we go back and we multiply all of them by 2 and write the new y coordinate. So the new y coordinate is negative 4, negative 2, 0, because 0 times 2 is 0, 2, and 4. Okay? Once we have the y coordinates, we're going to begin to graph it. Okay, and from the graph, we're actually going to transform it. Okay, move it up and down, left and right, depending on what type of problem we have, or how many k units and h units we have. So, continuing on, we're going to draw a coordinate plane. Now remember, when you draw the coordinate plane, make sure you label everything. Okay, the more you label, the more information you have in case you make a mistake. Okay, and the more information other people have when they're trying to read the graph. So x, y, 1, 2, 3, 4, 5, 6, 7. Let me send it a little. 8. So this is 4, this is 2, this is 6, this is 8. 1, 2, 3. This is 2. 1, 2, 3. This is -2, -4. And then 1, 2, 3, 4, 5, 6, 7, 8. -4, -8, -6, and -2. We're going to begin graphing the graph that we have by multiplying everything by 2. That's going to be the red one. Now the red graph is not the final graph, it's just a mid step. Okay, the final graph is once we transform it. Okay, so we're going to have 0, 0, -1, 2, and -8, 4. On the other side, we're going to have 1, 2, and 8, 4. So it's a nice kind of fat looking graph. Okay, but we're not done. What we're supposed to do next is transform this graph. Okay, move all the points by however many units we need to move them up, and however many units we need to move it left and right. So look back at the problem. This number right here moves it left and right. This one right here moves it up and down. So since we have a -4, it means that all the points are moved 4 units down. And since we have a +1, it means that all the points are moved 4 units, or 1 unit left. So we're going to move it -1 units and -4 units. Okay? Telling you which direction we're going to go. So, the first point is over here. We have to move it left 1 unit, down 4 units. So it looks like it's going to go outside the box that we have. So we're not going to use that one. Just we know that it's going to go down here. For the second one, same thing. -1, -4. So all the way down here. Okay? The one after that is 0. So we move it left 1 unit, 4 units down. The one after that is 1. And the last one is this one. So 1 unit to the left, 4 units down. Connect the dots. Now it's going to be over the sign, that's fine. But when we draw them, this is what the graph looked like. Okay? And that's our final. Okay? Now notice that domain and range are still all reals. Okay? All we did was move the graph. Okay? And there's two types of movement and one type of enlargement / reflection. Okay?